So Unit 5 Basic Electronics. First topic Semiconductor. Or PN junction diode. Semiconductor or junction diode. In physics, we have studied about what is conductor, insulator, and semiconductor. What is a conductor? It is a material which is used for allowing the current to pass through it. We call it as conductor. Insulator means the material which does not allow the electrons to pass through it. We call it as insulator. Semiconductor means partially it will be allowing current and partially it will not be allowing current. We call it as semiconductor. Usually your semiconductor will be classified into two types, correct? In an intrinsic semiconductor and extrinsic semiconductor. What is the meaning of intrinsic? The purest form of semiconductor we call it as intrinsic semiconductor. When we have add impurities or dopings, we call it as extrinsic semiconductor. So your extrinsic semiconductor will be again classified into two types, P-type semiconductor and N-type semiconductor. So meaning of P-type semiconductor is P-type semiconductor. You will be having holes as your measuring carrier. In N-type, electrons will be acting as a measuring carrier. So holes means it is positively charged, electrons means negatively charged. So when you bring this P-type material with your N-type material, then we will be forming a PN junction diode, or it is also called as semiconductor diode. So when you bring the P-type and N-type together, it forms a PN junction. So here we will be having a single junction. So to operate this as a rectifier, we need terminals. So you will be considering two electrodes at your end of P-type and N-type. So these two electrodes are called as anode and cathode. A stands for anode and K stands for cathode. So symbol of this anode, cathode. So when you bring P-type layer and N-type layer together, you will be having a single junction. So in order to operate this, we need a metallic conductor. We used to call it as electrodes. So two electrodes are connected, one across your P-type and another across your N-type, and then it is anode and cathode. So anode means it is represented as A, cathode is represented as K. So symbol of PN junction diode. There you go. So in practical case, when you bring your P-type and N-type together, in P-type you will be having holes, in N-type you will be having electrons. So holes are represented by a circle, electrons are represented by dots. So in P-type, you will be having majority carrier will be your holes, and in N-type you will be having electrons. So when P-type and N-type are brought together, what happens here? At this junction, some of your holes will be passing into your N-type layer. Similarly, here what happens? Electrons will be passing towards your P-type layer. So this is positively charged and this one is negatively charged. We know when we So this ions are cannot be moved, so it is called as immovable ion. So this creates a layer called as junction form ஆயிடுது. So இதுல வந்து பாசிட்டிவ் சார்ஜ் இதுல நெகட்டிவ் சார்ஜ் இருக்கும்போது ஆப்போசிட் சார்ஜ்ல மூவ் ஆகும். மூவ் ஆகும்போது அயனைஸ் ஆயிடுது. ஸோ அயனைஸ் ஆயிடுச்சுன்னா என்ன அர்த்தம்? அது அந்த இடத்துல ஸ்டேபிளா நிற்கும், மூவ் ஆகாதுன்னு அர்த்தம். ஸோ இம்மூவபிளா ஆயிடுது. அப்போ உங்களுக்கு என்ன ஆகுது? ஆட்டோமேட்டிக்கா அந்த இடத்துல ஒரு லேயர் மாதிரி கிரியேட் ஆயிட்டா இந்த லேயர் என்னன்னு சொல்லுவோம்? புரியல? depletion region or actually அது என்ன சொல்லுவோம்? barrier potential. It acts as a gate. சரியா? So it is called as barrier. So இது positive இது negative னா it representing your voltage. சரியா? Voltage can be called as potential. So அதனால barrier potential. So this holes are connected to positive polarity and electrons are connected to negative polarity, then it is called as forward bias. So in forward bias, holes connected to positive polarity and electrons are connected to negative polarity. For reverse bias, opposite direction, holes will be connected to இந்த மாதிரி கிராஃப் போட்ட ஞாபகம் இருக்கா? PN division தெரியும்ல. ஸோ அப்போ இதை எப்படி எழுதணும்? Moving forward bias condition, as long as your external voltage is less than barrier potential, your current is almost zero. Current is almost zero. When your external voltage becomes greater than barrier voltage, your current flows rapidly. Forward bias. So when you plot a graph, you will be getting clear characteristics in this way. Practical நம்ம பண்ணும்போது 0.7 இல்ல 0.75 நமக்கு ரீசார்ஜ். சில பேருக்கு 0.8 வருது. புரியுதா? Reverse bias. What happens in your reverse bias condition? For reverse bias condition, first thing we need to change the polarity. That is, holes will be connected to opposite polarity, that is negative charge, and electrons should be connected to positive charge. இதனால இங்க என்ன நடக்கும்? So this is your positive charge. Your potential is at negative charge. So opposite charges na gets attracted. So your instead of hole moving, that is positive charge reaching your end layer, it will be flowing towards your positive polarity. Similarly, electrons will be moving towards your positive polarity. So அப்ப இது potential என்ன ஆகும்? Barrier potential இன்னும் பெருசா increase ஆகும். So width of your barrier potential gets increased. From initial value it gets increased. So width of your barrier potential gets increased. So no electrons or holes will be moving from p-type layer to n-type layer or from n to p-type layer. So conduction is not possible in your p-n junction diode during reverse bias condition. But what happens here? As long as you are increasing the value of your external sources, what happens to your p-n junction diode? p-n junction diode என்ன ஆகும்? ஒரு அளவுக்கு நீங்க வோல்டேஜ் இன்க்ரீஸ் பண்ணிட்டே இருக்கும்போது பேரியர் வோல்டேஜ் ஃபுல்லா வந்துட்டே இருக்குமா? வித் இன்க்ரீஸ் ஆகிட்டே இருக்கும். 120 பாயிண்ட்ல என்ன ஆகும்? லேயர் இல்லாத அளவுக்கு உங்களுக்கு ஃபுல்லா பேரியர் வோல்டேஜ் ஆயிடும். That point we call it as breakdown. Breakdown mechanism in reverse bias condition. So this breakdown will be classified into two types called as avalanche breakdown. Second one we call it as Zener breakdown. So during your reverse bias condition, since opposite polarities are applied to your p-n junction layer, as long as you are increasing your external voltage, barrier potential will gets increased. Therefore, the breakdown will be occurred in your p-n junction diode. This breakdown will be classified into two types: avalanche breakdown and Zener breakdown. So avalanche breakdown means it is called as carrier multiplication. diode itself. Manufacture பண்ணும்போதே extra impurities add பண்ணது ஜாஸ்தியா இருந்ததுன்னா ஒரு breakdown occur ஆகும். It is called as Zener breakdown. Avalanche breakdown தான் நமக்கு practical occur ஆகும். So meaning of avalanche breakdown is actually உங்களுக்கு இந்த electrons எல்லாம் இருக்கும் atom மாதிரி represent பண்ணிப்போமா, கரெக்ட்டா? So in the outer layer you will be having free electrons, கரெக்ட்டா? இதெல்லாம் ஞாபகம் இருக்குங்க. So 2 power n அந்த கான்செப்ட்ல நம்ம வந்து கால்குலேட் பண்ணுவோம். அப்புறம் அது கோவலன்ட் பாண்ட்ல இருக்கும். Some of your electrons will be acting as a free electrons. Bondingல இல்லாம இருக்கும். So இங்க நம்ம external pressure கொடுத்தோம் இல்லையா, voltage. So due to that pressure ஒரு electron free electron ஆக்ட் ஆச்சுன்னா இந்த pressure-னால இந்த electrons என்ன ஆகும், ஆல்ரெடி அது bondingல இல்ல, அப்பனா அது என்ன இருக்கு, லூஸா இருக்குன்னு அர்த்தம். So it comes out of your covalent bond. So அப்ப இது வெளியில வந்துரும். ஓகேவா? இது